camp. For this class, we're going to be doing 10 lessons, and 10 lessons for the most challenging or sections of Algebra 2 that a lot of students struggle with. All right, let's get started. All right, so for this section here, for the first lesson, we're going to be addressing a few things. We're going to be multiplying powers, raising powers to powers, dividing powers, exponent rules, exponential and radical form, exponential rules with fractions. So these are the sections that we're going to try to hit in this first lesson. All right, so let's jump into the first example. So for this first example right here, we're multiplying powers. And how do we multiply powers? We just need to remember a few basic rules. We need to remember that if I'm multiplying a to m times a to n, this here is going to be a to m plus n. So we're simply adding the exponents if we're actually multiplying. Now, the beautiful thing about multiplication, we can pretty much multiply in any order because of the commutative property. So what I'm simply going to do here, I'm going to put that together. So that's going to be -7 times -5 times x to the 5th times x to the 4th times y to the 3 times y to the 4th. So all I did there was just rearrange this to put the common things together that I can actually add the exponents. So with that being the case, 7 times 5 going to be 35. X to the 5th times x to the 4th simply going to be x to the 5 plus 4. And then we're going to have y to the 3 plus 4. So my final answer for this problem here is going to be 35 x to the 9 times y. 3 plus 4 simply going to be 7. And that completes this problem. So let's jump into the second problem. So I want you to pause the video firstly and then try this first before we start. All right, now looking at this, we can get rid of parentheses and then put the like terms to work with where we can actually multiply. So what we're going to do is there's an invisible 1 here that we understand. I'm going to do 1 times -3 times x times y cubed times y cubed. So this here going to give me -3 times, now there's an x to 1 here and there's an x to 1 there. Add the exponents. This is going to be 2 and this is going to be y to 6. So this here would complete that second example after you guys get a shot at trying this. All right, let's jump into the third example now. Now pause the video for a minute and I want you to try this. All right. Now, once you try this, let's look at this real quick. First, I'm going to get rid of the parentheses. I'm going to rewrite this as -5 times -6 times x cubed. So we're putting the x's together times y to the 5th times y to the 5th. As a result, 5 times 6 simply going to be 30. Now here, there's an invisible 1 there. 1 plus 3 going to be x to the 4. And then 5 plus 5 going to be y to the 10. So that completes that problem there for example 3. All right. Now once we finish that, we're going to jump now into raising powers to powers. So raising powers to powers, let's look at the first example that is given right here. We need to know the rule to raise powers to powers is as simple as this. If I have a to m over parentheses here, this is simply going to be a to m times n. Secondly, if I have a smaller variation of this rule, if I call this m and I call this n, and I'm going to raise everything to e, this is going to be a to m times e times b to n times e. So notice here is almost like I'm distributing the exponent outside to everything else. Doing the same thing for this here, I'm going to have 3. Now it is understood that there's a 1 there, so that's going to be 3 to 4, because that's 1 times 4, times x to 3 times 4, times y to 5 times 4. 3 to 4 going to simply be 81. 3 times 4 going to be x to 12. 5 times 4 going to be y to 20. And that completes this problem. All right, now try the second example. And after you try the second example, we're going to then jump into it. All right, having tried the second example, let's see what you get. So for this problem right here, we got 4x squared y to the 5th. It is understood that this is 4 to the 1 right there. So using the same rule again, we're going to have 4 to the 1 times 4 times x squared times 4 times y to the 5th times 4. This would give me 4 to 4 times x to the 8 times y to the 20. Now we're going to be 256. So this is going to be 256 times x to the 8, y to the 20. And that completes that problem. All right, now let's try the third example. Before I jump into it, I want you to pause the video and try this question. All right, having tried the video, try this question. Let's jump into it. So the first thing we're going to have here, we're going to have negative 6 all to the square times x to the 3 square times y to the 4 and the square. We're multiplying everything by 2. So negative 6 squared is going to be positive 36 times x to the 6 times y to the 8. So this here is going to complete this example for this particular example. All right, now what we're going to look at now, we're going to divide powers. And how do we divide powers? Let's jump into it. The first thing we need to do is recall the basic rule that is used to divide powers. We're going to have a to m divided by a to n. The rule is that we simply subtract the exponent. So this is going to be m minus n. So that's a very important rule that is used to divide exponents. Another thing that is used a lot when we're dividing exponents that we need to kind of pay attention to is also this rule. If I have a to the negative m, this here is going to simply be 1 over a to m. So let's jump into this problem. 3 goes into 3 one times. 3 into 27 going to be 9. So here, what I've realized, I can rewrite this. This is going to be 9 times x. The exponent here is 1, so I'm going to have 1 minus 8. That's going to be 1 minus 8. The exponent here is 3, so I'm going to have y to 3 minus 7. This is going to give me now 9 times x to negative 7 times y to negative 4. Now I can use this rule to rewrite both of these. This is going to be 9 times 1 over x to 7 times 1 over y to 4. Now this is 9 over 1, multiplying 9 times 1 times 1, going to simply give me 9. 1 times x to the 7 times y to the 4, going to be x to the 7, y to the 4. And that completes that problem. All right, let's jump into the second example. Pause for a minute and try this problem. Now looking at this problem, we know that there's a 1 right here. So 1 into 1 goes 1 times, 1 into 4 goes 4 times, so we don't need to even simplify anything there. So if I rewrite this, this is going to be 4 times x to 1, because there's an invisible 1 right here, minus 8 times y to 8 minus 7. So we get 4 times x to negative 7 times y to 1. So if we get y to 1, this here going to be 4 times 1 over x to 7 times y over 1, multiplying all of this, 4 times 1 times 1, 4 times 1 times y, going to give me 4y over x to 7. And that completes this problem. All right, let's jump into the next example. So for the next example right here, we realize now that 6 goes into 6 1 times, 6 goes into 18 3 times. So we're going to have 1 over 3 times, we have x to the 4th minus 6, because we're dividing this. Then we got y to the 7 minus 7. Now here, what we're going to have now, we're going to have 1 over 3 times x to the negative 2. Then we're going to have y to 0. Now a very important rule here that we're going to address is this rule as well. A to 0 is going to be equal to 1, especially when a is not equal to 0. This is the only time that this is not true. So any number raised to 0 or letter is normally 1, except when 0 is raised to 0. 0 to 0 is not 1. As a result, we're going to get 1 over 3 times 1 over x squared times 1. 1 times 1 times 1. For the top, the numerator is going to be 1 divided by 3x squared. So that there going to simply be my answer for this problem. Alright, so now let's jump into some exponent rules. And we're going to look now at the different rules that we can use with exponents. Alright, so let's jump into this problem right here and going over some basic exponent rules that we're going to need to use. So the first rule we want to use that we're going to be using a lot here is a to the m times a to the n, simply going to be a to the m plus n. Second rule, if we got a to the m divided by a to the n, this here going to be a to the m minus n. Third rule that we need right here, if I have a with negative m, this here going to be 1 over a to m. Now once I have these rules, now I can actually work these out pretty carefully. So the best thing to do for this problem right now is to firstly look at the top. So for the top, we got 20 times, this is going to be 1 over t to 6 times 1 over a to 3 using this rule. As a result, my top simply going to be equal to 20 divided by t to 6 a to 3. Alright, so that is the top. Now let's focus on the bottom. So to focus on the bottom, let's switch my colors. We're going to look now at this. Now, if you recall, there's a fourth rule here that we're going to use that's going to help us. If I have a to m to n, this is going to be a to m times n. So a to m times n, what I'm simply going to do, I'm going to distribute the negative for all of these using this rule. So this is going to be 4 to negative 2 times t to negative 3 times negative 2 times a to 2 times negative 2. So we understand that 4 is raised to 1, so we multiply negative 2 times 1. So let's work this out now. We're going to get 4 to negative 2 t here, negative 2 times negative 3, going to be 6 times a to negative 4. So this here works out to be 1 over 4 to 2 times t to 6 times 1 over a to 4. Working out all of these now, this is over 1 times t to the 6 times 1, going to simply be t to the 6 over 4 squared times a to the 4. So that's going to simply be that. So what I'm going to do now, putting both together, let me use a different color. Let's use put both together now. Let's do both together. So what we get for the top was 20 over t6 a to 3. This is my bottom. So what I'm going to do, keep change flip. So I'm going to have 4 squared times a to 4 all over t to 6. So with that now being the case, I'm going to get 4 squared, which is going to be 16. So this here is going to be 20 times 16 times a to 4. So what I'm going to do now, I'm going to work out the bottom. So I'm going to rewrite the t's. So this is going to be t to 6 times t to 6 times a to 3. So what I simply need to do now is multiply Now 20 by 16. 20 by 16 right here going to simply be 320. And if that is 320, I'm going to have times a to 4. Now what I can do a to 4 since I'm dividing, minus 3. And the bottom remained the same right here because the t to 6 is at the bottom. So I'm going to have t to 6 plus 6. So this here going to give me 320. A to 4 minus 1 simply going to be a divided by t to 6 plus 6. 6 times 2 is going to be 12. And that completes. Alright, so let's pause the visit for a bit and then try this problem. And then let's jump into it. Alright, so with this being the case, let's jump into this question. So the first thing we're going to do is, let's write the top. So this is going to be 3 x to 10 c to 10. For the bottom now, we got negative 4, so let's write back the negative 4. Then we're going to actually use this rule again, a to m times b to n. If I use e, this is going to be a to me times b to ne. So using that rule, we're going to multiply each exponent. So this is going to be x to 3 times negative 4 in the exponent times c squared times negative 4. So what do we get now? This is going to give us 3 to x to 10, c to 10. Bottom here, we're going to have negative 4. 3 times negative 4 going to be x to negative 12. And then 2 times negative 4 going to give me c to negative 8. Now I can actually work with each exponent. This is going to be 3 over negative 4 times x to 10 minus negative 12 times c to 10 minus negative 8. As a result, I'm going to get 3 over negative 4 times x to 10 minus 12. Negative 12 going to simply work out to be 22. And this is going to be 10 minus negative 8 going to be c to 18, and this completes this problem. Alright, so let's pause for a minute and then you're going to try this example. Alright, once you have tried this example, let's jump into this. Alright, so we got 12 divided by 4. That's the first thing. 4 is into 12, going to be 3. So we're going to have 3 at the top. Now we're going to have y to the 5th m. For the bottom now, since we get rid of that 4, we're going to use the same rule again. The rule is a to m times b to n. And if I'm multiplying this by e, this is going to be a to m times e times b to n times e. As a result, we're going to get negative 2 times 3. So negative 2 times 3 for that one. Then we're going to have m to 4 times negative 2. So what do we get right here? We're going to get 3y to the 5th times m divided by, we're going to have y, 2 times negative 2 times 3 going to be negative 6. 4 times negative 2 going to be m to negative 8. Now we can work with the like terms. So this is going to be 3y to the 5th minus negative 6 times m. Now this here is 1, if we understand that. So that's going to be 1 minus negative 8. That's going to give me 3y to 11, because negative times negative is positive. 5 plus 6 is 11. And then we're going to have m1, negative times negative is positive. So that's 1 plus 8, which is going to be 9. And this completes my problem. Alright, so let's jump into exponential and radical form. Alright, so with that, we're going to actually fundamental rules. The first rule that we're going to revisit right here is if I have the nth root of a to m, this is going to be equal to a. Now notice now, in my numerator for my exponent, I'm going to have m. So the m that is right here goes in the numerator. The denominator now going to be my n. So my n right here going to be in the denominator for my exponent. And that is how we switch from exponential format to radical format and back and forth. So let's look at the first example. So for the first example, what I'm simply going to have is x to the 3 over 2. This here is going to be, this 2 going to be in my root, and it's going to be x to 3. Now normally we don't write the square root. Once we have 2 here inside the radical sign, we don't write the square root. So this is normally written as just the square root of x to 3. So that is how I switch from exponential format to radical format. So that's the first example. Now let's jump into the second example real quick. So for the second example, we're going to have the 5th root of x to 4. Here again, we're going to switch now to exponential format from radical format. So this is going to be x. This 5 going to be in my denominator for my exponent. So that's going to be 5. And this 4 right here going to be in the numerator for my exponent. So that's going to be 4. And that complete that problem. Now let's switch my colors again. Let's this time use purple. For the third example, we have the same situation. Here, we're going to have the cube root of x squared. To switch, notice again, I'm going to have x. I'm going to put the 3 that is in my root in my denominator for my exponent. So that's going to be 3. And the 2 right here going to be in my numerator. So that is how I exponential rules with fractions. So with this now, the rules are pretty much the same. We're going to, again, if you recall, that if we have a to the m divided by a to the n, this here going to simply be a to the m minus n. And the rule that we just did, if I have a to the n, and I'm going to switch this up, I'm going to have the mth root instead, kind of switch up the here now. I'm going to have a, the root, the denominator now going to be m, switching the letters around just to play around with the letters, and then n going to be in the numerator. So if we understand this, this question is simply asking us to find what a is. We want a to 4 over 5 minus 1 over 2. So what we're going to do is, as a side note, to work that fraction out. So let me use a different color to work that fraction out. We're going to have 4 over 5 minus 1/2. To make the denominators be the same, I can simply multiply this by 2, multiply this by 2, multiply that by 5, multiply the top by 5. As a result, this is simply going to give me 10 as my LCM. 4 times 2 going to be 8 minus 5. This is simply going to be 3 over 10 for my exponent. So here, this is going to be x, which is going to be 3 over 10. So a is technically 3 over 10. But one of the things here that I want you guys to be comfortable with, again, is to write this using this format. So let's switch it. This here going to be the 10th root of x to 3 if I would switch it to that format. So that there complete that problem. All right, so let's try this one now. Pause for a minute, and I want you to try it, and then let's resume in a second. All right, having done this problem, let's jump into it. Again, we're going to use this rule. We're going to have a to m times a to n. It's going to be a to m plus n. So if that is a to m plus n, what I know, working out this left side, I'm going to have x, the 3 over 5 plus 1/2. Now again, to add this, if I do 3 over 5 plus 1/2, multiply this by 5, multiply this by 2, multiply that by 2 to make the denominators be the same, we're going to get 10 over 3 times 2, which is simply going to be 6 plus 5. That's going to be 11 over 10. So this would work out to be 11x to 11 over 10. Now obviously a going to be 11 over 10, but again we want to be comfortable rewriting this in the radical format. So this is going to be the 10th root of x to 11, and that completes this problem. All right, now let's jump into this last question. And this is asking to select the equivalent expression, but here we're going to kind of just create an expression that kind of simplify this process problem. We want to review a few basic rules. The first rule that we need to be comfortable with, one, is if I have a to m times a to n, this is going to be a to m plus n. Secondly, if I got a to m divided by a to n, this is going to be a to m minus n. And then thirdly, if I have a to negative m, this is going to be 1 over a to m. And then fourthly, if I remember these rules, if I got the nth root of a to m, this is going to be a to, notice now, n going to be in my denominator for the root, and then m going to be in my numerator. So I'm going to have a to m over n. Alright, so let's jump into this problem. The first thing I'm going to do is work the bottom right here. So to work the bottom right here, I'm going to use the first rule. Using the first rule, this is going to give me d to negative 5. I'm going to be adding negative 4. So this is going to work out to be d to negative 9. So this is going to simply be 1 over d to 9. So if I put back everything right here, this is going to be 1 over d to 9. So that's simply going to be what is inside there. Keep, change, flip. This here going to give me d to 9. Now that is d to 9. What I'm going to do now is find the 6th root of that. So finding the 6th root of d to 9, I have to be d. I'm going to put my numerator here to be actually 9, and my denominator going to be the 6 within the root. So that's going to be 6. So this is also equal to d. 3 into 9 going to go 3 times. 3 into 6 goes 2 times. So this is d to 3 over 2. And that would be an equivalent expression for this problem.